Jai Hind children, welcome to today's class. In the last class we have studied about algebra of complex numbers. Today we are going to study about some more properties. Let us start. Multiplicative inverse is denoted by Z inverse. For a complex number Z equals A plus IB, its multiplicative inverse is, already you studied that the multiplicative inverse can be written as 1 by Z. 1 by Z equals 1 by A plus IB. But 1 by Z can also be represented as Z inverse. So Z inverse equals 1 plus 1 by A plus IB. You know how to find 1 by A plus IB. You have to multiply the numerator and denominator with the conjugate or with the A minus IB equals A minus IB in the numerator by the denominator is of the form A plus IB into A minus IB. What is A plus B into A minus B? A square minus B square. B square means IB the whole square equals A minus IB divided by A square minus I square B square equals A minus IB divided by A square minus I square is minus 1 into B square. Therefore, Z inverse obtained as A minus IB divided by A square minus of minus is plus B square. Next, we can study about what the modulus of a complex number. Modulus is usually represented like this. Read it as mod Z. For a complex number Z equals A plus IB, its modulus is denoted by mod Z like this. Mod Z equals, the formula is square root of A square plus B square. What is A, which is equal to root of? What is A? For the complex number, the real part of the complex number equal to A and the imaginary part of the complex number equals B. So, I am going to change the formula as, instead of A square, I am going to write which is the real part of Z the whole square plus imaginary part of Z the whole square. So, this is the formula for to find the modulus of a complex number. Modulus of a complex number, very important formula. Mod Z equals square root of real part of Z square plus imaginary part of Z square. For example, consider a complex number Z equals 3 minus 2i. What is the modulus of Z? Mod Z equals square root of real part of Z the whole square plus what is imaginary part? Imaginary part is the part which comes along with the I, that is minus 2 the whole square equals root of 3 square is 9 plus minus 2 the whole square is 4 equals root 13 is the answer. So, mod Z equals root 13. Now, we are going to study about the properties of modulus of complex number. First property is, for any complex number Z, mod Z equal to 0 implies that the complex number Z will be 0. Z0 means that a real part of the complex number will be 0 and imaginary part of the complex number equal to 0. For a complex number Z equals real part 0, imaginary part 0, then only you can say that modulus of Z will be 0. Second property is, for to find the modulus of the product of two complex numbers Z1 and Z2, it is equivalent to finding the modulus of the first complex number into the modulus of the second complex number. And third property is modulus of Z1 by Z2. For to find the modulus of the quotient of two complex number, find the modulus of the first complex number divided by the modulus of the second complex number. These are the three properties you need to study in the case of modulus of a complex number. Next, we are going to study about the conjugate of a complex number. Conjugate of the complex number is usually represented as Z bar. Read that Z bar. For a complex number z equal to a plus ib, its conjugate is z bar equals a minus ib. What we mean with that? For to get the conjugate, you need to change the sign of the imaginary part. Change the sign of the imaginary part of the complex number. For example, if z equals 2 plus 3i, then the conjugate z bar equals, change the sign of the imaginary part, 2 minus 3i. Another example, if z equals the complex number 2 minus 3i, then the conjugate z bar equals 2 plus 3i. Suppose the complex number z equals minus 2 minus 3i, then the conjugate z bar equals, change the sign of the imaginary part a lot, that is minus 2, changing the sign of the imaginary part becomes plus 3i. And if the complex number z is of the form minus 2 plus 3i, then also the conjugate will be z bar equals minus 2, change the sign of the imaginary part, minus 3i. So this is the way for to find the conjugate of a complex number. Now we are going to study some important properties of conjugate of a complex number. The first property states that if z1 and z2 are two complex numbers, then taking the sum and finding the conjugate is equivalent to find the conjugate z1 plus find the conjugate of z2 separately. That is z1 plus z2 the whole bar equals z1 bar plus z2 bar. Second property states that z1 minus z2, that is difference of two complex numbers, then finding the conjugate is equal to find the conjugate of the first complex number minus find the conjugate of the second complex number. That is z1 minus z2 the whole bar equals z1 bar minus z2 bar. The third property states that z1 into z2, find the product of two complex numbers and then take its conjugate, is equivalent to z1 bar into z2 bar. Find the conjugate of each number separately and then multiply. And the fourth property states that z1 by z2, find the quotient of two complex numbers, and if you want to find the conjugate, it will be equivalent to z1 bar by z2 bar. So these are the four important properties of conjugate of a complex number. Now we are going to study a very important result in complex numbers. For any complex number z equals a plus ib, z into z bar equals modulus of z square. This is the result. Z bar equals mod z square. This is a very important result in complex numbers. Here, you know that z equals the complex number a plus ib. Then what about z bar? Z bar is the conjugate of this number. How to find the conjugate? Change the sign of the imaginary part. Then the last one, mod z. What is mod z? Mod is equal to square root of the real part the whole square plus imaginary part the whole square. This is mod z square. Mod z. Then if this is mod z, what about mod z square? The square root get rid of. Okay. We can check whether this is true. Using an example, z equals 5 plus 6a. Consider a complex number z equals 5 plus 6a. I am going to find, let z equals 5 plus 6a. Here, what about the real part of the complex number is 5. What about the imaginary part of the complex number is imaginary part is 6. At first, I am going to find the multiplicative mod z. Mod z equals square root of real part the whole square plus imaginary part the whole square equals square root of 25 plus 36 equals square root of 61. This is mod z. If mod z equals root 61, what about mod z square? Mod z square equal to square root of 61 the whole square, which is 61. Now, one more value I need to find, z bar. If z equals 5 plus 6i, what about z bar? Changing the sign of the imaginary part, 5 minus 6i. Now you have z bar equals 5 minus 6i, mod z square equal to 61, and the complex number z equals 5 plus 6i. We can verify this result. Before that, by usual method, we can find the multiplicative inverse. The multiplicative inverse of the complex number z is, the multiplicative inverse is, how to find the multiplicative inverse? 1 by z. 1 by z means 1 by, what is the value of z here? 5 plus 6i, the complex number. You know how to make a simplification. Multiplying the numerator with 5 minus 6i, the same factor you need to multiply the denominator, 5 minus 6i. Now equals 1 into 5 minus 6i is 5 minus 6i divided by, the denominator is of the form a plus b into a minus b equals a square. A square means 5 square minus b square. B square is 6i the whole square equals 5 minus 6i divided by 5 square is 25 minus 6 square is 36 into I square equals 5 minus 6i divided by 25 minus 36 into I square is minus 1. Okay, 1 by z equals 5 minus 6i divided by 25 minus 30 minus of minus 2, that is plus 1. So this becomes plus 36 equals 5 minus 6i divided by 61. I am going to write this value here. What obtained for you? Thus we have 1 by z equals 5 minus 6i divided by 61. But what is 5 minus 6i? 5 minus 6i is equal to z bar by, what is 61? 61 is mod z square. What about the left side? 1 by z. Thus 1 by z equal to, the multiplicative 1 by z equal to z bar by mod z square. This result you can use for to find the multiplicative inverse of a complex number. For to find the multiplicative inverse, 1 by z equals z bar by mod z square. But our aim is to find the result z bar equal to mod z square. Okay, we can arrive at the result, cross multiply, get z into z bar equals 1 into mod z square, that is mod z square. So very important result, z bar equal to mod z square. But this result is very important for finding the multiplicative inverse of a complex number. Let's do a problem. Before starting, remember the formula for to find the multiplicative inverse. 1 by z equal to z bar by mod z square. Very important result for to find the multiplicative inverse of a complex number. Using this result, we are going to find the multiplicative inverse of, first question, 4 minus 5a. What you want to do that, given number you need to take as z. Let z equals 4 minus 5a. Find the real part of z equals 4. And what about the imaginary part of z? Equals the term which comes, or number which comes along with the I, that is minus 5. I am going to find the multiplicative inverse 1 by z. The formula states that z bar by mod z square. Find z bar at first. Z bar equals the conjugate of the number 4 minus 5i. The conjugate of this number is z bar equals, how to find the conjugate of a complex number? Change the sign of the imaginary part. So becomes 4 plus 5a. This is z bar. Z bar equals 4 plus 5a. Now I want to find mod z square. Find mod z. Mod z, the formula is square root of real part the whole square plus imaginary part the whole square. This is the conjugate of a complex number. Sorry, modulus of a complex number equals square root of, what is real z? Real z is 4. So 4 square plus Imaginary z is minus 5. So minus 5 the whole square equals square root of 4 square is 16 plus minus 5 the whole square is 25 equals square root of 41. This is the value of mod z. Thus mod z obtained for s minus 41. Sorry, root of 41. Mod z equals root of 41. Now we are going to find the multiplicative inverse 1 by z. We have 1 by z equals z bar by mod z square. This formula you need to write it first. Equals z bar is 4 plus 5i divided by mod z is root 41. So mod z square is root 41 the whole square equals 4 plus 5i divided by root 41 square is 41. This much is enough. If you want, we can express it in the form of a plus ib as 1 by z equals 1 by z equals. Writing in the a plus ib form, we can write as 4 by 41. 4 by 41 plus 5 by 41i. Usually we write complex numbers in the form of a plus ib. So 1 by z equal to the multiplicative inverse 1 by z equal to 4 by 41 plus 5 by 41i. This is the multiplicative inverse of the complex number 4 minus 5i. I will do one more question. Consider another number z equal to, let z equal to 2 minus 3i. We are asked to find the multiplicative inverse of z. At first you need to write what about a real part of z. A real part of z is 2 and imaginary part of z, the number which comes along with I, that is minus 3. Next you need to find z bar. Z bar means 2 minus 3i the whole bar. You need to find the conjugate of this number equals 2 minus 3i becomes plus 3i. This is z bar, the conjugate of z. Next is finding mod z equals square root of real part of z the whole square, that is 2 the whole square plus imaginary z the whole square minus 3 the whole square equals root of 2 square is 4 plus minus 3 the whole square is 9. 9 plus 4 is root 13. This is mod z. Now I am going to find the multiplicative inverse. Therefore the multiplicative inverse of z is multiplicative inverse of z is 1 by z. The formula is z bar by mod z square equals, what is z bar? Z bar is 2 plus 3i divided by mod z is root 13, so its square equals 2 plus 3i divided by root 13 the whole square is 3. This much is enough. If you want, you can arrange it to the form of a plus ib as 1 by z equals 2 by 13 plus 3 by 13i, separate division 3 by 13i. This is the multiplicative inverse of the complex number 2 minus 3i. Another problem. Expressed in the form of a plus ib for the number, complex number is given for you 5 plus root 2i divided by 1 minus root 2i. You need to express the given complex number in the form of a plus ib. For to express the number in the a plus ib form, you need to make a simplification. You are given that 5 plus root 2i divided by 1 minus root 2i. If there is a denominator, you know how to make a simplification. Multiply the numerator and denominator with the conjugate of the denominator. What is the conjugate of the denominator? 1 plus root 2i. 1 plus root 2i. You have to multiply in the numerator as well as in the denominator. 1 plus root 2i. This is the first step. Given number, if it has a denominator, multiply the numerator and denominator with the conjugate of the denominator. Equals, multiply inwards, 5 into 1, 5, plus 5 into root 2i, 5 root 2i, plus root 2i into 1, root 2i. Next is plus root 2 into root 2 is 2. I into I is I square. The whole divided by denominators of the form a minus b into a plus b. A square minus b square. B square means root 2i the whole square. Which I am going to make a simplification as 5 plus 5 root 2i plus root 2i plus 2i square is minus 1, the whole divided by 1 square is 1 minus root 2 square is 2, I square is minus 1. Root 2 square is 2, I square is minus 1. Again equals, I am going to combine 5 plus 5 root 2i plus root 2i. 2 into minus 1 minus 2, the whole divided by 1 minus 2 into minus 1 plus 2 equals, we can combine 5 minus 2, combine the real part, 5 and minus 2, 3. Imaginary parts, 5 root 2 plus root 2, root 2 means 1 root 2. 5 root 2 plus 1 root 2 is 6 root 2i, the whole divided by 1 plus 2 is 3. If one, you are asked to find the numbers in the form a plus ib. Therefore, the given number is, the given number in the form a plus ib is, in the form a plus ib is 3 by 3 plus 6 root 2 by 3. Give the denominator separately, I. If 1, you can cancel 3 by 3 is 1 plus 6 by 3 is 2 root 2i. So the answer is 1 plus 2 root 2i. Next we are going to study about the organ plane, otherwise called as the complex plane. In simple, we can say that the plane which is used to represent complex numbers is called as the complex plane or organ plane. You know that corresponding to every ordered pair of real numbers xy. For example, consider a real number 2, 3. For this ordered pair of real number 2, 3, you can locate you have a unique location for the point 2, 3 in this plane. X value 2 and y value 3. Let this be x value 2, y value 3. This be the point. This point represents 2, 3. Remember, this is the point in the Cartesian plane in which this axis you may call it as the x-axis and this axis is called as the y-axis. Now, the point 2, 3 has a unique location in this plane. This is in the case of the real number system. In the same way, corresponding to each complex number, consider a complex number 2 plus 3i. Corresponding to this complex number, I can make an ordered pair as 2, 3, in which the first or the x coordinate will be the real part and the y coordinate represents the imaginary part. Here, in the element or in the ordered pair 2, 3, we can say that this represents the real part of the complex number and this represents the imaginary part of the complex number. Am I right? 2 plus 3a. What is the real part of z? The real part of z equal to 2 and this represents the imaginary part. So, corresponding to each complex number, we can mark an ordered pair 2, 3 or in general for any complex number xy, we can take an ordered pair as xy in which the first point or the x value represents the real part and the y value represents the imaginary part. Now, I am going to locate the point 2, 3 corresponding to the complex number 2 plus 3i in this plane. X value 2 and y value 3 I am going to mark here. But this is the location of the point 2, 3 in this plane. But instead of the coordinate as 2, 3, this point represents the point P which corresponds to the complex number 2 plus 3i. Am I right? Corresponding to the complex number 2 plus 3a, if I can find a coordinate 2, 3 that represented in this plane as 2 plus 3a. But here the x-axis is called as the real axis and the y-axis can be termed as the imaginary axis. Imaginary axis. So the point P equal to the or complex number Z equals, we can mark it as Z, the complex number Z equals 2 plus 3a can be represented in this plane in which the x-axis is called as the real axis and the y-axis is called the imaginary axis. This plane which represents a complex number is called as the Argand plane or the complex plane. So the definition of the Argand plane is that the plane having a complex number assigned to each point. For each point there exists a complex number. Corresponding to this point you can find a complex number in which the x value is -1 and the element in the real axis is -1 but the element in the imaginary axis is -1. So this represents the complex number -1 in the real axis plus I into -1 in the imaginary axis. So this represents the complex number -1 minus I. So corresponding to each complex number, suppose you are going to take a complex number here. Here this point represents x value 2 and y value also 2. So even if you write it as 2, 2, actually it corresponds to the complex number 2 plus 2i, where 2 is in the real axis and this represents 2 in the imaginary axis that you need to attach with I, 2 plus 2i. Thus, the plane having a complex number assigned to each of its points is called as the complex plane or the Argand plane. Remember, in the complex plane or Argand plane, the x-axis is called as the real axis and the y-axis is called as the imaginary axis. A very important point try to remember this case is that consider this point again. I am going to mark a complex plane here in which this axis represents the real axis and this one represents the imaginary axis. Suppose I am going to locate the point x value 2 and y value 3. Suppose I am going to locate a point in this plane. Then this represents the complex number Z equals x value 2 means the real value 2 plus the imaginary value 3. So 2 plus 3a. But if I join these two, you know that this is actually the coordinate 2, 3. Corresponding to this complex number 2 plus 3a, the coordinate is 2, 3. Now, if you find or if you join, this can be taken as the original, join O to Z. This represents OZ, represents the distance of the point 2, 3 from O. Consider this Argand plane in which you know that the x-axis represents the real axis and the y-axis represents the imaginary axis. If I take a point Z here, this point Z corresponds to, in the real axis the value is 3 and in the imaginary axis the value is 2. So this represents the complex number Z equals 3 plus 2i. I am going to find the modulus of Z. Mod Z equal to square root of the real part the whole square plus the imaginary part the whole square equals root of 3 square is 9 plus 2 square is 4 which is root 13. Find the distance. O means the origin which represented by the point 0, 0. That also can be think as a complex number having real part 0, imaginary part 0 or which corresponds to the complex number. Here the origin corresponds to the complex number 0 plus I 0. Origin corresponds to 0 itself. If I join O to Z, you know that this is the distance of the point from the origin. The distance of the point Z from the origin is OZ. Last year you studied that the distance formula OZ equals root of x2 minus x1 the whole square, that is 3 minus 0 the whole square, 3 square plus y2 minus y1 the whole square, 2 minus 0 the whole square, 2 square, then also root 13. So from this you get a clear idea that distance of a complex number from the origin. Distance of a complex number from origin where in the organ plane from origin in the organ plane, that will be equal to the modulus of the complex number. It equals a plus ib, then o is the distance will be root of a square plus b square or mod z. Remember this. For any complex number, the distance of the complex number from the origin equal to the modulus of the complex number itself. But consider some points in the real axis and imaginary axis. Consider a point 2 in the real axis. If the point is in the real axis, you know that the imaginary value is 0. As per the Cartesian point, any point in the x-axis has its y-coordinate 0. So, this point corresponds to the coordinate 2, 0, or it corresponds to the complex number z equals 2 plus I 0. Remember, any point in the real axis has the y-coordinate 0. So, it corresponds to the complex number z equals 2 plus I 0, which is purely real. A complex number having imaginary part 0 is called as a purely real complex number. So, if any point in the or if the points in the real axis correspond to purely real complex numbers. And in the same way, come with the imaginary axis. Here you can see a point 3 in the imaginary axis. Any point in the y-axis has its x-coordinate 0 and the y-coordinate is 3. This represents the complex number z equals 0 plus 3i, which is a complex number in which the real part is 0 and imaginary part is 3, which is purely imaginary. So from this you can say that every point in x-axis represents a purely real complex number, and every point in the y-axis, each and every point in the y-axis represents a purely imaginary complex number. So remember these points about the organ plane. Now we are going to solve some quadratic equations. Consider the equation x square plus 2 equal to 0. You know that to get the solution x square equal to minus 2. From this x equals square root of minus 2, as per the last year definition, you know that it is not defined. But not defined where in the real number system it is not defined. But now we have a solution, which implies this x can be written as square root of 2 into minus 1 equals root 2 can come out and root of minus 1 separately equals root 2 into root of minus 1 is I, root 2i. So the solution you can write as x equals plus or minus, two values will be for a quadratic equation, plus or minus root 2i is the solution of this equation. Consider another question. Solve x square plus x plus 1 equal to 0. If you find the discriminant b square minus 4ac, you can see that b square 1 square minus 4 into a is 1 into c is 1 equals 1 minus 4 equals minus 3, which is less than 0. You studied that if b square minus 4ac is less than 0, it has no real solution, but it has imaginary solution. Here the solution is, you know how to find the solution of a quadratic equation. Therefore, the solution is no real solution, but we can find an imaginary solution. The solution is x equals minus b plus or minus root of b square minus 4ac the whole divided by 2a equals minus the value of b is 1 plus or minus root of, now I need to find b square minus 4ac again, b square minus 4ac obtained to us minus 3 divided by 2 into the value of a is 1 equals minus 1 plus or minus, now root 3 can't come outside, you can directly write it as root 3i divided by 2. Why? Because you know that root of minus 1 is I. This can be split up as minus 1 plus root 3i by 2 and other value is minus 1 minus root 3i by 2 are the solution of this equation. Therefore, the solution is x equals minus 1 plus root 3i by 2 and minus 1 minus root 3i by 2. From this it implies every quadratic equation has a solution. In case if b square minus 4ac is less than 0, as per the real number system, even if it has no solution, but the imaginary system or the complex system, it has a solution that we are not how to find it. Now down the homework questions.